Hello, everyone. Welcome to our presentation. These are proof tasks, and we are going to take you through. And my name is Kwame.
My name is William Khan.
My name is Guilherme Coelho.
And I am Yasser.
Yeah, and then the next one. So basically, I'm just going to take you through what the presentation is about. Our presentation is under telecommunication systems engineering. And what we are going to present is the difference between AM, FM, and then PM, for which the three is amplitude modulation, the first one. Then FM is the frequency modulation, and then the PM is the phase modulation. And we are going to take you through to see the differences with the graph and then the code as well. So my colleague is going to take you through a code.
So here we have first our first the laboratories that we use, NumPy and Matplotlib. And the parameter that we use the frequency as 10,000 for the sampling frequency. And the time vector we used 0, 1, and 1 for divided by the frequency. For the message signal, we use message frequency as 5, and for the message amplitude we take 1. And the formula was m is equal to am multiplied by np cosine 2n pi for frequency multiplied by the time. For the carrier signal, we have the carrier frequency equal to 100, and for the carrier amplitude, it's equal to 2. And the formula is carrier is equal to carrier amplitude multiplied by np cosine 2 np pi carrier frequency multiplied by the time. For the amplitude sensitivity, we took 0.7, and we have the formula AM is equal to AC plus KA multiplied by the mass multiplied by NP cosine 2 NP pi frequency multiplied by the time. For the FM, we take frequency sensitivity equal to 50, and FM is equal to AC multiplied by NP cosine 2 NP pi frequency multiplied by the time plus 2 NP pi frequency multiplied by NP multiplied by M divided by the frequency also. For the phase sensitivity, we took it equal to 2, and the formula PM is equal to AC multiplied by NP cosine 2 NP pi frequency multiplied by the time plus KP multiplied by the mass. For the plotting, now we take the plotting and try to convert this value to figure using the second library, which is Metasploit. Yeah, we have the first one, the figure, and the second one, PLT subplot and PLT plot and PLT title. The title is message signal, and the label is time. The other label is amplitude, and we have the full graph. For the second graph, we have the title is amplitude modulation, and the label is time, and the other label for the y direction is amplitude. For the third graph, we have the title is frequency modulation, and the x label is time. For the y label, it's amplitude. And for the first one, we have the amplitude modulation AM as a title. And for the X label, it's time. And for the Y label, it's amplitude. For the last graph, the title is phase modulation, PM. And the X label is time, and the Y label is amplitude. And now we use plt.show to show all of the graph that we took.
So here we go in our message and graph that we can see the signal from the AM. You guys can see the message signals here is showing like that's the good part of that. The AM, the frequency is constant, but the amplitude is gonna is if you see these signals, it seems like it's sinusoidal. So it's moving in how we call the rate is changing, but maintained in the same level. So that's what happened with amplitude. For AM modulation, the same thing you can see here is just showing like the for the frequency still is constant, but for AM amplitude is not constant, varies. So for the frequency modulation, FM is different. In this case, the frequency tells us the amplitude is constant, but the frequency is what change. So this is the two different things. If you when you have FM, when you have AM, the only two different is like one have both of them have amplitude and also a frequency. But what changed them is the one is constant, one changed. So that's the difference between AM and FM. For the modulation, phase modulation is different. In this case, sometimes is that he's changed, but not directly. He just go indirectly, so that you can see in this graphic about the frequency modulations doesn't really change that much comparing to the probably phase modulation PM. You can see maybe because of the graphic shows like the phase modulation is probably more thin than the frequency one. But what we say is like the 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 noise in frequency is higher, different the amplitude is less. So the graphic just shows how everything flows. So this is what I want to explain. And then we're going to my friend is going to explain the another part of the job. So I would like to say, let's go.
Okay, I'm going to explain some part of the work. My friend that already did some parts about coding and others. So I'm going to do the last part, and here is the table that I'm going to explain. It's about AM, which is amplitude modulations, FM, and then PM. So the table is here, the pictures and what changed, and amplitude of current, frequency of current, and pace of current. Signal equations are under what changes. So AC plus M multiplied by 2. Then frequency varies with message. Then phase carries with message. Band wide, low, and under AM. Then high under PM. Then also in high in PM. So noise immunity pro in AM, good in PM, very good in PM. Conflictuality is simple under AM, moderate under FM, and then conflicts under phase modulation. Power efficiency low in AM, high in PM, then also high in PM, FM. Yeah. Application AM radio, that is under AM, then FM radio broadcasting, digital communication, phase shift key, and carrier frequency, constant under AM, various under FM, then constant under PM. Sensitivity factor, amplitude sensitivity, which is under AM, frequency sensitivity under FM, then phase sensitivity under PM. So this is the last part, and yeah, and this is my group, all of us. Yeah, I think we can stop from here.